again. Next section is the same thing as the last, but with tangent. We're going to talk about what happens when you have the tangent of two things added or two things subtracted. Just as a review from the section on sine and cosine, can't distribute trig functions over addition or subtraction. Totally not allowed. If you have add or subtract with a trig function, you have to apply a formula for it. So the two formulas for tangent are at the top page of your notes. I'm going to go through a few examples now to show you how to apply them. So let's start with a problem like example 1, where I want the tangent of alpha, the tangent of beta to be equal to 1/3 and 1/2, and I want the tangent of alpha plus beta. So I'm going to apply the first formula, where alpha is the a in the formula and beta is the b in the formula. And just like we did in the last section, alpha and beta are just a Greek a and b. So when you plug them in for this particular problem, it's going to be equal to the tangent of alpha, using that top formula, plus the tangent of beta over 1 minus the tangent of alpha, tangent of beta. And all you have to do now is plug those values in. So we'll go ahead and plug them in. I'll go over here. The tangent of alpha is 1/3. The tangent of beta is 1/2 divided by 1 minus the tangent of alpha, 1/3, times the tangent of beta, 1/2. And now this goes back to a few sections we've done where you have to try to combine this to as small as possible. And this is that visit the pieces thing where you're going to go ahead and get a common denominator and then all the denominators cancel out. So the common denominator is 6, 3 times 2. So this guy's all done, but I'm going to go visit each fraction. So this first fraction is missing a 2. So I'm going to give a 2 to the top and the bottom. This fraction's missing the 3. So I'm going to give him a 3 on the top and the bottom. This one's missing both, but 2 times 3 is 6. So I'm going to do it as a 6 over 6, and that guy's done. And remember what that allows me to do is cross out all the denominators. You can only do this when you're getting the common denominator. And so what's left is the numerator. 2 times 1 is 2, plus 1 times 3 is 3, over the denominator, 6 minus 1. They multiply out to 1. And when you simplify, you get 5, in this case, over 5, which does reduce this whole thing to a 1. They don't all reduce to a 1. That's kind of nice that this one worked out. If it reduced to a fraction, you'd leave the fraction as is. Now I want to show you how to work one backwards. So in this one, I wanted to find the alpha plus beta and apply the formula giving everything out. Now I want to work it backwards and see if I can match this formula to the right-hand side of one of those. So if I have a plus here and a minus there, it looks like I'm still working with the formula I used in example 1, but now I'm going to work it backwards, where the 100 is the A and the 50 is the B. And you'll notice that matches up to be an A here and a B here. Working that formula backwards, that means all of this is the tangent of A, 100 degrees, plus B, 50 degrees, which is the tangent of 150 degrees. So now you have to know where 150 degrees is on your unit circle. So 150 is over here in the second quadrant. If I know the coordinates over here, this is going to be a reference angle of 30. So they go with the 1/2, the pi over 6, and the radical 3 over 2 in those locations, but the x is negative. And so the tangent, if you remember, is the y over the x. So to solve this problem, the y coordinate is 1/2. The x coordinate is negative radical 3 over 2. And then you're going to simplify that. You could just worry about the numerator over the numerator, but just so you remember, if you want to write out all the work, you take the top number and you leave it alone, and then you flip the bottom number over. And so that'll be a negative 2 over the square root of 3. You can go straight across or see that those 2's cancel. Negative 1 over the square root of 3 would then rationalize radical 3 into negative radical 3 over 3. And that's how I would want your answer for that section. So what's going to happen, like the last section with the sines and cosines, is everything should work out to something on your unit circle. In the next few examples, I'm just going to show you how to apply these more. And I'll leave the formulas here on my PowerPoint. You may have to turn the page to go back and forth. So you write down any questions you might have while I erase. And I'll answer them when we get to class next. And on the next slides here, you see we have an evaluate with a variable in it, like I did with x's with sines and cosines. And then I'm going to do one where you have to evaluate without a calculator or a table, and you have to know the combination. In this one, we're going to apply the formula for subtraction because it's the tangent of two things subtracted. So in the subtraction formula, I'll make that A and that B. And this will be the formula I'll use. So in this one, let's see what I have. Tangent of A is 3 pi over 4. Then it has minus the tangent of B, which is theta, over 1 plus, this one has a plus on the bottom, tangent of A, 3 pi over 4, tangent of theta. Now you have to evaluate these things. In this particular problem, we can go ahead and evaluate the tangent of theta because that was given to us to be 1/3. The tangent of 3 pi over 4, you need to know. 3 pi over 4 is in the second quadrant. Using all students take calculus, I know it's going to be negative, so I'm just making a note here that the tangent of 3 pi over 4 is a negative, and at 3 pi over 4, that's going to be the radical 2 and radical 2 thing. That's going to reduce to a 1. Again, look on your unit circle. So when I take this number, plugging that in, I get negative 1 minus the 1/3, because that was given for the tangent of theta, 1 plus now negative 1 times 1/3, plugging everything in for the values. I would get a common denominator like I did in the last problem. This one needs a 3 over 3 and a 3 over 3, and then all those bottoms cancel. So on the top here, I get negative 3 minus 1 over, be careful, 3 minus 1. You have a plus, a negative, and another plus. So I get negative 4 over 2, which is negative 2. This one reduced like example 1, but again, they won't always. Simplify as much as you can. In our last problem, we're going to try to find the tangent of something like 105 that's not on our circle, but we're going to do it using things that are on our circle. And here's where you have to get creative. You have to think of combinations of items on the circle that will get you to 105. For example, 105 degrees can be broken down into 60 degrees plus 45 degrees. Okay, well if I turn the tangent of 105 into the tangent of 60 degrees plus 45 degrees, 60 and 45 are both on my circle, so I can use those. It's super helpful. So if I can go ahead and apply a formula, conveniently, that first one will work, where A is the 60 and B is the 45, I can go ahead and evaluate. I won't need a calculator or a table. I just need my unit circle. Applying the formula, tangent of A, which is 60 degrees, plus the tangent of 45, because that's my B, over 1, this one has a minus in it, the tangent of 60 degrees, tangent of 45 degrees. Now the tangent of 45 degrees I know is 1. Tangent of 60, I have to do a little bit of work. Remember, we have our little first quadrant thing that's going on here. At 60 degrees, which is pi over 3, I have 1/2, comma radical 3 over 2, and you probably already have that little cheater column done in your notes, and that's going to be radical 3 over 1. So when I plug this in, I'll have radical 3 plus the tangent of 45 is 1 over 1 minus the square root of 3, and the tangent of 45 again is 1. I'm going to let you leave that like that. Technically, just so you know, this radical 3 can't technically be in the bottom, so we'd have to use the conjugate to simplify it. So to simplify, you would need the conjugate. And if we have time in class, we'll go ahead and go over that when we go over homework problems. So these are just a few examples where you're using the tangent of two things added or two things subtracted. And again, if you have any questions, make some notes for them, and I'll go ahead and answer them when I see you in class. Bye-bye.